In order for refiners to handle crudes they may not normally be able to process, additives and additional techniques are required to prevent fouling issues. When these additives reduce problems in refinery operations, economic benefits are realized. Crudes supplied to storage tanks in a transportation system handling heavy asphaltenic crudes and light paraffinic oils often require pretreatment to break emulsions and disperse waxes. Additives are also used to reduce heat exchanger fouling. Electrostatic desalting, which is used to prepare crudes for the CDU, often requires additional techniques that remove contaminants that cause fouling. Additives may be applied at several stages of the refining process as needed. Additives added to crude entering refinery tanks are surfactants for pretreating, asphaltene stabilizers, solvents and surfactants to prevent sludge deposition, hydrogen sulfide scavengers, etc. Additives for emulsion breaking, solids conditioning and wetting agents, contaminant removal, fouling control, etc. are added in treating, desalting, and preheating systems. Finally, additives for corrosion inhibition, contaminant removal, fouling control, wastewater treatment, etc. may be added throughout the refinery. Such additives can be vital in processing troublesome crudes. Companies that supply chemical additives often promote the potential benefits of chemical additive programs, such as those that remove metals and other contaminants from refinery feed streams, improve desalter efficiency, reduce the burden of desalter effluent water treatment, and limit downstream fouling and corrosion, among other benefits. The table summarizes the solutions chemical additives provide, and the resultant benefits for the refinery. As mentioned previously, refiners can potentially reduce problems with fouling by using chemical additives. Here is a non-inclusive list of companies that supply refiners with such chemical additives. Here is our sponsor's experience. In order to properly engineer a lifespan fouling control program, Baker Hughes, a GE company, begins with a fouling root cause analysis to identify the source of fouling, the mechanism of fouling, and solutions, both operational and chemical, to mitigate fouling. This analysis incorporates a detailed unit survey to understand the fouling history and operational impacts on the unit. Analyzing the deposit that has formed in the unit reveals the source of the fouling problem. Such analyses can quantify inorganic salts, inorganic corrosion products, or identify the functionality of the organic foulant that has contributed to the deposit. Feed characterization is a tool to help identify the mechanism that is causing the fouling. A typical approach is to characterize the feeds analytically by a specific set of compositional parameters known to indicate fouling potential. Fouling mechanisms are determined by which parameters exceed concern levels. In addition to the deposit and feed characterization work, proprietary fouling studies can also be completed on the feed streams to various units to evaluate the performance of antifoulants and guide the development of appropriate treatment strategies.